Hello guys, welcome back to Amit Dhakad. In this video, we will learn about RAG. So imagine asking an AI assistant what happened in the news this morning and actually knows, or uploading 500 pages of legal documents and asking a specific question and precise answer. That's the magic of Retrieval-Augmented Generation, or RAG. In the next 15 minutes, you will be understanding exactly how it works, why it matters, and how to think about building it yourself. So here what we will cover today. So the problem RAG solves. What is RAG? The RAG pipeline and embeddings and vectors, retrieval strategies, and real world use cases. Let's dive in. So first we need to understand why RAG is exist. Like first why it exists. So look at the left side. What LLMs are coded: writing, reasoning, and summarize. Converse naturally, training on massive data sets like ChatGPT, Claude, LLMs, and more. Look at the right side. They have limitations. Knowledge stops at training date. No access to the private data. Can confidently hallucinate facts and frozen and cannot self-update. These aren't the bugs. These are limitations. They are fundamentals to how LLM works. The model is frozen at a training time and it cannot reach out to the world. But our application needs fresh and private and accurate info. Let's go deeper into the two main limitations. Two critical limitations of LLMs, like knowledge cutoff and no private data access. So every LLM is trained on data up to the certain date. After that date, it knows nothing. Ask it about like yesterday's earning report or recent court rulings. It's completely in the dark. Saying that these models were trained on the public internet data. They knows nothing about your company's internal documents, product and manual patient reports, or any code base. So these are the two limitations of the LLM. So here you can see visually on the left all the things LLM cannot see, like today's news, here company stocks, latest research, only what was the available on the internet, and internet at a training time, and RAG is what tears down the wall at a query times. Okay, so what do you do? You could fine tune the model, but that's expensive and you still need to doesn't handle the real time information. To a smart answer for that, give the model the information it needs. So that's the exactly what is RAG. RAG stands for Retrieval Augmented Generation. So that's the name say it's all, like retrieval. Find relevant documents from your knowledge base. Augmented, add the retrieved information to the prompt. Okay, and generation, let the LLM generate a grounded and accurate response. So think of like a open book exam. Instead of relying purely on what the student memorized, they get the look things up first, then writing the answer. So the student, the LLM is still doing the reasoning, but now they have the right information in front of them. So what is like RAG and simple RAG pipeline? So user asks question and it will retrieve and it will augment it, like it will add the retrieved information with the prompt and it will send to the LLM and it will the answer. So like example, what is our refund policy? So it will retrieve a refund policy documents, it will augment prompts in that and generate like return accepted within 30 days. So what is RAG? RAG versus fine tuning. So fine tuning bakes knowledge into the model weights. It's like training the student for months so they can memorize everything. It works, but it's slow and expensive. And RAG is giving the student a library card, immediately updatable, scalable, and much cheaper. So for most real-world application, use this the RAG, the right tool. So this is two-phase pipeline. So first is indexing. So let's walk through the complete RAG pipeline step by step. There are two major phases: indexing and querying. First, indexing. Load the document. You start with the raw data, PDF, Word document, web pages, or database email. You load them into the pipeline. Chunking the documents. So large documents are split into the smaller manageable chunks, typically 200 to 2000 tokens each. Why? Because LLM have limited context window and smaller chunks retrieved more precisely. This step is more important than people think. Embedding. Each chunk is converted into the vector embedding. List of numbers that capture the semantic meaning of the data text. We explore this more in the next segment. storing in the vector database. So those embeddings are stored in the specialized database like Pinecone and ChromaDB that can perform ultra-fast similarity search. Phase 2 querying. So user asks a question like user submit a question like what is our refund policy? So it will be the query. This question is converted into the embedding and using the same embedding model that we used in the indexing. Retriever, the vector database finds the chunks most similar to the query, and this is typically called a top key search and returning the 3 to 10 most relevant chunks. And augmented, the retrieved chunks are injected into the LLM prompt alongside with the original question. LLM reads the context and generates the response grounded in the retrieved facts. So this is the same load documents, PDF, Word docs I explained. So like chunking, creating, embedding, storing database. So user query, so that we need to convert in embeddings. It will search the similarity search, augmented and generation. So here exactly what the LLM sees, a system instruction telling it only is the context. The retrieved chunks as context and user questions the model, reasoning over this and produce a answer. System adding the prompt. Like you are a helpful assistant, always only using the context below. If the answer is not in the context, say I don't know. So our refund policy allow return within 30 days of purchase item and must be original condition. To initiate return, visit returns.example. These are the chunks. What is the refund policy? So you can return item within days of 30-day purchase as long as they are in the original condition. So embedding are the backbone of the RAG. So let's understand this. So an embedding is a mathematical representation of text, a dense vector of hundreds or thousands of floating point numbers. So what's powerful is that semantically similar text produce symmetric close to each other. So car and automobile will be close together in the vector space. Kings minus men plus women equals to queen. So that famously the geometry inputs meaning. So look at the visual on the right. So here, look at the visual on the right. Transport words cluster together. Medical terms cluster together. Geographical cluster together. This is the semantic space retrieval operation. So modern embedding model like OpenAI, text embedding, pre-large or open source model like sentence transformer can convert a paragraph of text into the vector with 768 to 3072 numbers. Vector database. So vector database is built especially to store and search these high dimensional vectors efficiently. A vector database is built especially to store and search these high dimension vectors efficiently. Popular options including Pinecone for managed production use, ChromaDB for local development, Weaviate for multiple model data, and Qdrant for high performance Rust-based development. So the key matrix is cosine similarity, measures the angle between two vectors. So the closer to 1.0 and the more semantically similar to the text are. Retrieval strategies. So not all retrieval is equal. The quality of what you retrieve directly determines the quality of your answer. Here are the key strategies. Dense retrieval. Embedding based on semantic search. It's great to find conceptually related content even if the exact words differ. So what are your shopping rates? Can match a chunk that say delivery cost and fees. So not all retrieval is equal. So the quality of what you retrieve is directly determine the quality of your final answer. So here are the key strategies like dense retrieval, sparse retrieval, and hybrid search. Dense retrieval is embedding based semantic search. It's great at finding conceptually related content even if the exact words differ. So what are your shopping costs? You can match a chunks that say delivery fees and rates. Sparse retrieval uses traditional keyword search like VM25. The algorithm behind Elasticsearch, it's great for exact match, produce codes, invoice number and technical terms. So invoice number so it will exact match invoice document. So precise exact match retrieval, no embedding needed. So token query into turf, local inverted index, score for VM25, TF IDF formula and rank by relevant score. Hybrid search combines both, use dense retrieval for semantic matches and sparse retrieval for keyword precision. So the re-ranking result with cross encoder. This is approach used in production systems. So dense search top K semantic, sparse top K search. It will merge and it will re-rank and use the cross encoder. For advanced use cases, these are the powerful technique. Hide, generate hypothetical answer first, embed that, then retrieve. Often finds far better results than embedding the raw question. Re-ranking, query expansion, and parent-child chunking. So re-ranking each cross encoder model to re-rank the top K results for higher precision. Query expansion rewrite the user query into multiple variants to improve recall. And parent-child chunking. Retrieve small child chunks for precision, pass their larger parent chunks to the LLM for richer surrounding context. Once you have retrieved the right context, it's time for LLM to generate response. So the step is more nuanced than it looks. Watch out for the lost in the middle problem. So research show that LLM tend to recall information at the beginning and end of a long context better than the middle. So place where most critical chunks first and last. So hallucination guard. Guarding against hallucination. Even a good context model can hallucinate. Keep retrieved context concise as lower temperature settings. Implement output validation and monitor faithfulness continuously. So instruct model a base every statement on retrieved context. No context, no claim. Temperature, low temperature, concise context, output validation, Regus matrix. Faithful. It is the answer grounded in the retrieved context. Answer relevance. Does the answer directly address the user questions, cases of topic, or Vegas response? Context precision. Are the retrieved chunks actually useful? Penalize noisy and irrelevant retrieve results. Context recall. Did retrieval surface all the needed information? Missing context leads to incomplete. So real world use cases. Where RAG science. So first, RAG isn't theoretically. It's powerful. Some of the most impactful AI application built today. Enterprise use like enterprise knowledge base, building a RAG for answering question and answering for employees. Employee queries, wikis like HR policy and run books in the natural language. Customer support board. RAG powered boards full from product documents and past tickets to the answer complex question, accurately reduce the ticket volume by 40 to 60. Legal research. Lawyers and clinicals uses RAG to query case law or medical literatures and get verified summaries in the minutes instead of hours. Code assistant. Tools like GitHub Copilot retrieve relevant code from your repository before generating answers. Personalized educations. A student asks about their specific course material gets tailored answer. Let's wrap up. Here what you learned today. LLM have knowledge cutoff and can't access the private data. So this problem solved by the RAG. RAG is Retrieval-Augmented Generation. Like retrieve the chunks, it will augment it with the prompt and it's sent to the LLM, then answer. Like find, add context and then answer. Two phases. Indexing, like chunking, embedding and stores. And second is querying, like retrieve, augmented and generate. Embedding encode the semantic meaning. Vector DBs enable millisecond similarity search. Hybrid search, dense, sparse and re-ranking gives the best production accuracy and evaluate the RAG faithful answer and relevant context precision and recall. So these are some resources you can check out like LangChain, LLM Index for RAG framework, vector database we have Pinecone, ChromaDB, Qdrant, embedding models, OpenAI text embedding 3 layers, Hugging Face sentence transformer, and Coherent embed version 3. Evolution, Regus.io, TrueLens, and Weaviate. Thank you for watching. You will now understand the Retrieval-Augmented Generation. Please like if this helps, subscribe for next videos, and click on the bell notification icon. Thank you.